Welcome and a very good evening, ladies and gentlemen. Welcome to yet another episode of Perceptive Learning Zone. Sorry, I've been somewhat unavailable in the meantime. There's been a massive interval on account of my illness. But now that we are back, we'll just pick the discussion up from where we were last talking about. We were talking about the current trends in the field of chemical engineering, and we are just wrapped it up, talked about blockchain as well as IoT and artificial intelligence in our last conversation. And today we shed a look at the future. What are the future global trends in this field? Yeah. So when we talk about the future of chemical engineering, I think it is very important that we talk about nanotechnology. And nanotechnology is revolutionizing chemical engineering by manipulating materials at the molecular level. It is enhancing the reaction efficiencies. It is creating advanced filters for air as well as water purification. And it is basically improving the efficacy of medications. So it can also contribute to the development of targeted drug delivery systems as well as high performance materials with applications in electronics as well as energy storage. Now, we also need to talk about artificial intelligence and machine learning at this stage. It is driving significant advancements in chemical engineering in terms of improving process control, reducing the waste, as well as enhancing our level of productivity. So, predictive maintenance that is being powered by artificial intelligence, it helps prevent equipment failures as well as substantially minimizes the downtime. And AI driven simulations, well, they allow engineers to test the different scenarios and optimize our process parameters. So as AI as well as machine learning evolves, they will continue to revolutionize chemical engineering and basically offer new tools for process optimization and innovation. Comprende? Moving on, renewable energy sources, they are crucial in driving innovation in chemical engineering. So engineers are constantly exploring ways to integrate solar, wind, as well as biochemical into chemical processes, which can power chemical plants, which can lower our global reliance on fossil fuels, as well as reduce the carbon emissions. Now, advances in biofuels as well as biomass conversion technologies, they are offering sustainable alternatives to traditional energy sources. Now, chemical engineers, right? They are constantly developing processes to convert the waste into valuable energy products, contributing to a circular economy. IKEA is a perfect example of a circular economy. They're aiming for a full circular business scale model by the year 2030, which includes innovative and sustainable schemes like furniture take back and resale. Now, innovations in energy storage systems such as advanced batteries, they are enhancing the efficiency of renewable energy use. So the what we perceive is that the push towards renewable energy that is fostering new research as well as development in chemical engineering, hence consequently promoting sustainability and environmental responsibility. So it is not wrong, I guess, to say that the future of chemical engineering is bright with advancements in nanotechnology, with artificial intelligence as well as renewable energy. And nanotechnology is enhancing material properties and creating new applications, whereas AI and machine learning, it is optimizing the chemical processes as well as improving efficiency. So renewable energy sources are driving innovation and promoting sustainability, hence shaping the future of the world. And while we're at it, it is very important that we talk about another important uh, future chemical engineering trend, and that is green chemistry. Now, what is green chemistry? Ladies and gentlemen, green chemistry is a key concept in the quest for sustainable chemical engineering practices. It involves designing chemical processes and products in a way that eliminates or reduces the use and generation of hazardous substances. Mhm. It also uses a lot of automation. So I was once coming across an ocean cleanup project that involves basically the use of autonomous systems for the removal of plastic waste from the oceans. Nowadays, in cities like Singapore, which are cramped for land area, we are seeing how vertical farming is slowly but surely refining the strip. Now you have hydroponics, you got AI, and a combination of controlled environments that are allowing crops to be grown in urban areas, hence resulting in less usage of water, less soil pollution, less environmental emissions. And similarly, you have Singapore's Marina Reservoir, which functions as a freshwater reservoir, as a flood containment system, as well as a recreational point. And similarly, there's a building in Amsterdam by the name of Edge, which is one of the greenest office buildings known for its integration of solar systems, of energy efficient appliances, as well as the use of smart lighting. And another application of green chemistry lies in the design of the Boeing 747 Dreamliner, which uses carbon fiber reinforced composites instead of aluminium to make an aircraft that is much lighter in weight, that has greater fuel efficiency and has less emissions. And research has, gone off at a very accelerated rate. You wouldn't believe it now. Uh, you got these transparent solar panels that are being installed now in windows, to capture energy, generate electricity, hence effectively converting your skyscraper into a power generation station. Um, the graphene filters are now being used to remove salt from seawater, hence increasing our access to clean drinking water. There are even scientists are even working on devices that sort of harness our body heat and convert it into electricity, hence powering our smartphones as well as sensors in our body. So, like I said, green engineering is the next big thing as far as future trends in chemical engineering is concerned. And this approach, what we gotta also understand, my dear students, is that it not only minimizes the environmental impact, but it also improves the safety as well as the health of workers and consumers. So you have companies now like Dow Chemical, Patagonia, Google, as well as Starbucks, which are taking proactive steps to integrate sustainable practices into their operations. Hence, reducing their environmental impact and positioning themselves as leaders in a rapidly evolving industry. So, furthermore, when we talk about future trends in the sector, we need to understand that there is also biotechnology as well as bioengineering, and these are crucial components of the future of chemical engineering, with their integration into chemical processes presenting potential for revolutionizing the industry. So, by using biological systems, organisms, and derivatives, these fields are developing innovative solutions for industry challenges. They are optimizing chemical processes and hence leading to greater efficiency and improved product quality. So the future of chemical engineering, it lies in the utilization of bio-based materials as well as renewable sources to replace traditional fossil fuel derived feedstocks. Now, bio-based materials derived from biomass sources like plants, algae, and waste products, they offer a sustainable alternative to conventional materials in various industries. And integrating renewable sources like solar energy, wind power, and biomass into chemical engineering processes, it reduces the greenhouse gases and increases the resource efficiency. So, biotechnological advancements are poised to disrupt the chemical engineering landscape by introducing innovative solutions that are more sustainable, that are more cost effective and efficient. You have biocatalysts, you got genetically modified organisms, as well as metabolic engineering techniques, which are optimizing chemical reactions. They facilitate the production of high value chemicals and reduce the production costs effectively. Bioprocesses are improving the production of specialty chemicals, fine chemicals, as well as pharmaceuticals, which is enhancing the yields, enhancing the purity, and increasing the degree of selectivity beyond the traditional chemical methods. So the future of this field, I feel it is also witnessing a very significant shift towards process intensification as well as miniaturization, which is revolutionizing the way chemical processes are designed as well as carried out. Process intensification, well, it involves maximizing the performance of chemical processes by increasing efficiency and improving the overall productivity. So this can be achieved through novel reactor designs as well as advanced control systems. Now, the benefits of smaller scale processes in chemical engineering, they include improved energy efficiency, enhanced process control, reduced waste generation, and increased safety. So there are several forward-thinking companies which, lo and behold, are steadily embracing the trend towards process intensification and miniaturization. And they're setting new standards along the way. You have Siemens, you have Evonik Industries, there is BASF, there is the Lanza Group, LONZA, which are leading the way in this direction. And they are demonstrating the growing momentum towards smaller but more, what shall I say, efficient systems in chemical engineering. Also, we have to talk about the fourth industrial revolution and the impact it is having on our sector. That digitalization and industry 4.0, it is revolutionizing the chemical engineering industry by integrating digital technologies into all aspects of the industry. And digitalization, it enables real-time monitoring of processes, resulting in better control and optimization of the operation, right? So Industry 4.0 technologies such as IoT devices and sensors, they are facilitating data collection, and this is fundamentally leading to enhanced decision making as well as predictive maintenance. So automation is playing a crucial role in reducing manual labor and human errors, improving safety as well as productivity in the chemical plants. Also, we talk about big data analytics and process automation and how they are emerging as key drivers of efficiency and innovation in the chemical engineering sector. They're offering unparalleled sights into operations, and they enable the industry to achieve greater levels of optimization. Big data analytics is now allowing chemical engineers to analyze the vast amounts of data to identify patterns, trends, as well as anomalies. And this is leading to optimized processes as well as improved performance. Now, process automation, it involves the use of intelligent systems to control and monitor manufacturing processes in real time. And this is resulting in increased efficiency and reduced operational costs. However, that being said and done, digital transformation is presenting several challenges that have to be addressed. Now, one of the key challenges, like I talked about in and I've mentioned this before in my cybersecurity series, is one of the key challenges is data security as well as privacy concerns. As you know, the increased connectivity of systems is leaving them vulnerable to cyber threats. And implementing digital technologies, it requires significant investments in equipment, in software, and training. And this, more often than not, ladies and gentlemen, can be a significant barrier for smaller companies within the industry. Now, on the other hand, digitalization also opens up new opportunities for innovation, for collaboration, for sustainability, hence driving the industry towards a more competitive future. So in conclusion, to summarize everything, I would say that the future of chemical engineering is poised for transformative changes driven by several key innovations. And nanotechnology, advances in nanomaterials, artificial intelligence, machine learning, renewable energy sources, biofuels, waste to energy technologies, and energy storage systems, they are driving these developments. So By embracing these technologies and addressing the challenges they present, the industry can combine to innovate and thrive in the years ahead. That'll be all for now. In the upcoming video, we'll do a detailed analysis on to whether or not a degree in chemical engineering is worth it in today's world. So please stay tuned and do not forget to like, share, and subscribe and reach out in the comment section in case you have any queries. Thank you very much and have a good night, fellas. Assalamu alaikum.